Today on Capecchi's Corner, we're going to look at proving triangles congruent, and we're going to take a look at Hl Theorem. This will be day one. Previous ways that we have used to prove triangles congruent include SSS, which stands for side, 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 SAS, which stands for side, angle, side, ASA, which stands for angle, side, angle, and AAS, which is angle, angle, side. Hl Theorem stands for hypotenuse leg theorem, and what this theorem states is if the hypotenuse and a leg, and that means either leg, of one right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. So if you look at our diagram and our markings, we have that the hypotenuse, remember the hypotenuse is the side across from the right angle, and each of these triangles are congruent. And here we have the legs are congruent. So if we have an hypotenuse and one leg, then we can use the Hl theorem. Now again, it states that either leg, so it doesn't have to be a specific leg. If you look at the diagram, there are two legs in a right triangle. So either of these legs, if they're congruent to a leg on the other triangle, then the triangles are congruent. So in the given triangles, we can say that triangle ABC is congruent to triangle DEF because those corresponding parts match up due to the Hl theorem. Something that you have to make sure you're paying attention to and you're noting when you're doing a proof using Hl theorem is you can only have a hypotenuse if you have a right triangle. And you can only have a right triangle if you have a right angle in your triangle. So if you're going to use Hl theorem in your proof as a reason to show congruency, you have to make sure somewhere that it states that there's a right angle in the triangle and that the triangle is a right triangle. In these three examples, we're going to state which congruency method or methods can be used to prove the triangles congruent. So let's look at number one. We have a right angle and we have one pair of sides that are congruent. I notice that my reflexive piece is also going to be congruent. Now remember, if I have a right angle, I want to look to see if I can use hypotenuse leg, but it doesn't necessarily always mean that I can. So I have an angle that is in between some sides. So that would give me side, angle, side. That's the reason those triangles are congruent. And looking at number two, again, I have a right angle, and this time I notice, remember, if this is a right angle, the other side is also a right angle. So I notice that my hypotenuse are congruent in either triangle. Again, I have a reflexive piece. And in this case, I can use Hl theorem because I have a right angle, I have the hypotenuse, and I have a leg. And the last one, number three, there's a variety of ways I can get congruency on this one. If I just look at the markings that I have side, angle, side, side, angle, side in both cases. I also notice that I have that reflexive piece, so that could also give me side, 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 because that would show that all three sides of one triangle are congruent to all three sides of another triangle. And again, if I'm paying attention, that reflexive piece is also my hypotenuse. It's right across from my right angle. So I also have Hl theorem because I have the hypotenuse and actually both legs, but I only need one leg to prove the Hl theorem. So in this case, this triangle can be proved congruent a variety of methods. Now that we've done a few examples, let's look at a proof. The given information says angle W and angle Y are right angles, and we have two segments that are congruent. Wx is congruent to Yx, those segments, and I'm trying to prove that segment WZ is congruent to segment YZ. Now in order to prove the sides are congruent, if I can prove that the triangles are congruent, then I can use CPCTC. So let's start with our given. It says Wx is congruent to segment Yx, so let's mark that. Wx is congruent to segment Yx. And then the second given says angle W and angle Y are right angles, so I'm going to mark that. Now, if I'm going to use Hl theorem, I have to decide that ahead of time before I get to the end of the proof, because if I am, I have to state that the triangles are right triangles. So I notice that segment XZ is reflexive, so I'm going to mark that to give me a visual. So because of that, I do have the legs were my given, and that reflexive piece is the hypotenuse, so I am going to use Hl theorem. So my next step, I have to state that the triangles are right. So I'm going to say triangle XWZ and triangle XYZ are right triangles. Now I know that's true because of the statement I had before, because I showed that there is a right angle in each of these triangles. So this is going to be because of definition of right triangle. Now my next statement, I'm going to talk about the reflexive piece that we already have marked up in our diagram. Segment XZ is congruent to segment XZ, and that's going to be because of reflexive. And then now I'm ready for my Hl theorem. I'm ready for congruency. I have stated that there's right angles. I've stated that there's right triangles. I have a hypotenuse that I've showed congruency. I have legs that I've showed congruency. So I can say triangle XWZ is congruent to triangle XYZ. And that is because of the Hl theorem. And now because the triangles are congruent, I can talk about any of the parts, corresponding parts being congruent as well. So my given statement is one of the sides. Segment WZ is congruent to segment YZ, and that is because of CPCTC.